So a random process is said to be stationary if all its statistical properties such as mean, autocorrelation, cross correlation, okay, so variance and movements and all does not change with time. Okay, if the statistical properties does not change with time, then those random variables are called stationary process. Those random processes are called stationary process. Okay, that is statistical properties does not change with time. Okay, so then the random process whose statistical properties does not change with time, those random processes are called stationary process. Okay, and we have discussed that the stationarity here. Stationarity depends on the probability density function, and we have discussed that we have different types of different orders or different levels of probability density function. So the uh, stationary process also have different levels and different orders. Okay, because depending on the probability density function only, we have statistical properties, yes or no? So statistical properties depends on probability density function. So here we have discussed that the stationary process will also depend on statistical properties. If the random process statistical properties does not change with time, then we say that this random process is called stationary process. Okay. So since the probability density function is having different levels, the stationary process depends on the probability density function. Okay, so that is why the stationary process also have different levels or different orders. Okay, so what are the different orders or different levels of stationary process? Here is the first order stationary process. First order stationary process. Okay, so then the second one is the second order stationary process. Third one is wide sense stationary process. Then fourth one is jointly wide sense stationary process. And fifth one is strict sense stationary process. Okay, so the stationary process have different orders. The first one is first order stationary process, second order stationary process, wide sense stationary process, jointly wide sense stationary process, and strict sense stationary process. Okay, so how do we call this as? We call it as WSS. Whereas this is JWSS, we call it as triple S, strict sense stationary process. Okay, so these are the different stationary process. Now first we'll discuss what is first order stationary process. Okay, so last class we have discussed this already. So we'll revise this here. First order stationary process. Okay. So here the random process whose first order, so here we will be considering a random process whose first order probability density function, first order probability density function does not change with time or shift in time. Okay, then that random process is called first order stationary process. Okay, so what is that? The first order probability density function does not change with time or shift in time. Okay, if there is a shift in time, even then the value will not change. Okay, so then that is called, that particular random process is called first order stationary process. Okay, so what is that here? What is the first order density function? Probability density function, it is given as fx of x comma t. Okay, or we can write it as fx of x1 t1 also. Okay, so here for example x of t is the random process, and at t is equal to t1. At t is equal to t1, we are getting the random variable x1. What is x1 here? X of t1. So at t is equal to t1, we are getting a random variable x1. What is x1? It is x of t1. Okay. In that case, what is the probability density function of this random variable here? It is given as fx of x1 t1 is equal to fx of x1. And if there is a change in time, how do you denote the change in time? So here we denote it as del t. Okay. So if the random process satisfies this condition, then that particular random process is called first order stationary process. Okay. And from this equation, we can say that fx of x1 t1 is independent of t1. It does not change with t1. Okay. It is independent of t1. Okay. And so that since it is independent of t1, what is the mean value of the random process is always constant. So what is the mean value of random process is constant. Okay. So what is the condition for first order stationary process here is the condition for first order stationary process is the mean value of the random process, that is x of t is equal to x bar. Is that x of t, how do you write it as x bar? It should be equal to constant. Okay. So this is the condition for first order stationary process. Okay. So now we'll discuss what is second order stationary process. Second order stationary process. So here the a random process is said to be second order stationary process if its second order joint probability density function does not change with time or shift in time. Then that is called second order stationary process. Okay. So that is a random process whose second order joint probability density function, because we are using two random variables here, so it is second order joint density function. So then it is not changing with respect to time. So for example, if you take x of t is the random process, it is the random process. Here we are getting two random variables. What are the random variables? X1 and X2, and t is equal to t1 and t2. So what is x1? X1 is x of t1. What is x2 here? It is equal to x of t2. Okay. Then what is second order probability density function? The second order probability density function is given as fx. We are getting these random variables from the random process x only. So it is write it as fx. Okay. x1, x2 from a time t1, t2 is unknown. A time instance t1, t2 is equal to what? It is fx of x1, x2, t1 plus del t. Okay. So it is t1 plus del t, t2 plus del t. So it is equal to what? It is equal to, here I write, it is fx of x1, x2, t1 plus del t, okay, t2 plus del t. Okay, so if any random process satisfies this condition, that is the second order joint probability density function is not changing with respect to time, then particular random process is called second order stationary process. Okay, then what is the condition for second order stationary process here is the autocorrelation function is independent of t here. It depends only on tau. Okay. So what is the condition here is that, for example, we take a random variables x1, x2 or the two random variables. Okay. The autocorrelation function between these two random variables. How do we write it as? The the autocorrelation function can be written as Rxx of T1, T2. Okay. At T1 we are getting the random variable x1, at T2 we are getting the random variable x2, which can be written as expected value of x of T1, x of. Okay. So since here we have assumed that say T1 is equal to T. Okay. Then what is T2 will be? T2 will be T plus tau. T2 will be T plus tau. What is tau here? Tau is the time difference between T1 and T2. Okay. So in that case, how do we write this? We write it as what is tau? Tau will be T2 minus T1. Okay. So what is Rxx of T1 comma T2 now? T1 comma T2 will be expected value of x of t, x of t plus tau. Okay. So now if you observe this, it is function of tau. What is tau here? Tau is the time difference. Okay. Now it is not function of t. Okay. So Rxx is not function of t. It is function of tau. Okay. So what is first order stationary process? In first order stationary process, the first order probability density function does not change with time. Okay. So it has to satisfy this condition. Then what is the condition for first order stationary process? That is f(x) of x1 t1 is independent of t1. It does not change with time t1. Okay, so that the mean value of random process is constant. So the expected value of x of t will be equal to constant. Okay, this is the condition for first order stationary process. Okay. Now for the second order stationary process, what is the condition? The second order joint probability density function does not change with time. Okay, it has to satisfy this equation. Then this is called second order stationary process. Okay. And what is the condition here? The condition is that the autocorrelation function is function of time difference. It is not function of absolute time t. Okay. So this is our first order and second order stationary process. Now we'll discuss what is wide sense stationary process. Okay. So wide sense stationary process. So what is wide sense stationary process? A random process is said to be wide sense stationary process. Uh, for a random process to be wide sense stationary process, that random process should be second order stationary process. Okay. So if a random process x of t is second order stationary process, then it is called wide sense stationary process. When it is called wide sense stationary process. Okay. So what are the this wide sense stationary process is also called weak sense stationary process. Okay. This wide sense stationary process is also called what? Weak sense stationary process. Okay. It is also called weak sense stationary process. The conditions for wide sense stationary process is, what is the first condition? Here we have to I forgot to discuss one more point here. All second order stationary process or first order stationary process also. Second order stationary process are all first order stationary process also. Okay. Now what is the condition here? The expected value of the random process should be equal to constant. So it has to satisfy the condition. First condition that the expected value of a random process should be equal to constant. The second condition is that the autocorrelation function, that is x of t plus tau. Okay, expected value of x of t, x of t plus tau should be function of time difference, that is tau. Okay, it is not function of t. It is independent of t. Okay, it depends only on time difference, independent of t. Okay, it depends on time difference. Okay, if these two conditions are satisfied, then what is this called? This is called wide sense stationary or weak sense stationary. Okay, So now we'll discuss what is joint sense stationary. So jointly wide sense stationary. Jointly wide sense stationary. Okay. So what is jointly wide sense stationary? Here we will be considering two random variables. Okay. So random process. We will be considering two random process x of t and y of t are the two random process. Okay. And these two random processes are jointly wide sense stationary only if the cross correlation of these two random processes should be function of time difference. Okay, it is not function of absolute time. Okay, so what is that? These two random process x of t, y of t should be function of the, say here random process x of t and y of t are the random process, and the cross correlation of these two random process should be function of time difference, okay, and it is not function of absolute time. Okay, if it is not function of absolute time, then we say that these two, then this random process is called jointly wide sense stationary process. Okay, so what is that here? That is Rxy of t1 comma t2 can be written as expected value of x of t1, y of t2. Yes or no? X of t1 and y of t2. Just now we have discussed that. What is t1? We have taken as t. Okay. Say t2 minus t1 is equal to tau. t2 minus t1 is equal to tau. Then what is that here? Rxx of t1 comma t2 can be written as expected value of x of t, y of t plus tau. Okay, whereas this will be function of what? Tau. It should be function of tau. Okay, what is tau? Tau is the time difference. Okay, and it is independent of absolute time. Okay, but function of time difference. It should be function of time difference. So then if any two random process satisfies this condition, then those two random processes are called jointly wide sense stationary process. Okay. Now what are the conditions for jointly wide sense stationary process here? The conditions are here that since we are using two random processes here, that the expected value of first random process, that is x of t, should be equal to the constant. This is our first condition. The second condition is expected value of the second random process y of t is equal to constant. Okay. Then the third condition is that expected value, the cross correlation, that is x of t, y of t plus tau. X of t, y of t plus tau will be equal to r xy of tau. Okay, that is, it is independent of t, depends only on time difference. Okay, so for any two random process to be jointly wide and stationary process, what are the conditions it has to satisfy? These are the three conditions it has to satisfy. That is, expected value of x of t should be equal to constant, expected value of y of t should be equal to constant, expected value of, that is the cross correlation between the random process x and y should be depends only on time difference. It does not depend on absolute time. Okay. So then this random process is called jointly wide sense stationary random process. Okay. Now we'll discuss what is strict sense stationary random process. Just know the strict sense stationary process. Okay. So if a random process x of t is said to be strict sense stationary process, if its nth order joint probability density function does not change with respect to or does not change with time or change in time, okay, shift in time, okay, then that random process is called strict sense stationary process, okay. That is nth order joint probability density function does not change with time or shift in time. Okay. Then that is called, that particular random process is called strict sense stationary process. Okay. Now we'll discuss what is nth order joint probability density function. So we are getting this probability density function from the single random process x. Here we write it as fx. What are that? It is nth order, means how many random variables will be having? N number of random variables, x1, x2, so on, xn. How we are getting this random variables? At t1, t2, so on, tn. Other time instance where we are getting this n random variables. Okay, so it is equal to what? It is equal to, with the time, with the change in time, it does not change. So it is equal to xn at t1 plus del t, t2 plus del t, so on, tn plus del t. Okay. So then if the random process satisfies this condition, if the random process satisfies this condition, then this random process is called strict sense stationary random process. Okay. And this is true for all values of x1, sorry, t1, t2, so on, tn and delta. For all the values, it should be true. Okay. And this strict sense stationary process is also called nth order. It is also called nth order stationary process. Okay. So this strict sense stationary process is also called, what is the other way? Nth order stationary process. Okay. So what is the condition for strict sense stationary process? It should be stationary. It should be stationary for all values of n. All values of n. It should be stationary for all values of n. Okay, that is n value is varying from 1 to capital N. We are taking nth order joint probability density function now. So it should be stationary for all values of n where n is equal to 1 to n. Then the process is called strict sense stationary process. Since it is stationary for all the values of n, this is also called nth order stationary process. Okay. So here, for example, if you take any random process x of t, say x of t is a random process, and it is stationary for only some values of n. It is stationary for k values. Okay. When k value is less than or equal to n, then this random process, what is this random process is called? Kth order stationary process. This random process is called kth order stationary process. Okay. So what is strict sense stationary process? So for strict sense stationary process, nth order joint probability density function does not change with time or shift with the time. So it has to satisfy this condition. If this condition is satisfied, then the random process which is satisfying this condition is called strict sense stationary process. Okay. And so whichever random process, so here we are taking a random process, it is stationary for all values of n where n is equal to 1 to n. Then this is also called strict sense stationary process, and it is also called nth order stationary process because it is stationary for all values of n. So that is why it is also called nth order stationary process. For example, you take a random process, it is stationary for only k values, where k is less than or equal to n. Then what is this called? Kth order stationary process. Okay. So these are the conditions for stationary process. So here we have discussed the 5 stationary process. So the first one is first order stationary process, second one is second order stationary process, third one is wide sense stationary. Okay, the fourth one is jointly wide sense stationary process, and fifth one is strict sense stationary process.